In this video, we'll quickly do linear and quadratic functions. So it's kind of a revision, and we will not get too much into the depth of this topic, as we'll be covering only those areas which we require in order to understand the fundamentals of physics. So let's get started. So the first thing in it would be the equation of linear function. Well, the equation of a linear function looks like this: y equal to mx plus c. So as you can see, it's a linear expression both in x as well as y. And if you try to draw the graph of this linear function, that means putting the values of x and correspondingly getting the values of y, when we plot its graph, the graph comes out to be a straight line graph. So what are these m and c? Well, they are constant. The c is basically the y-intercept of the straight line, because if you put x equal to 0, you are going to get y equal to c. So basically, y-intercept is that point on the y-axis where the straight line is going to cut. So the coordinates become 0, c. So we can write it over here. C is y-intercept. Now what about m? Well, m is the slope of the straight line. Now what is meant by slope? Well, if you look at the straight line and the angle it makes with a positive x-axis, so this is going to be the angle, and let's say this angle is theta. Now we define slope m, it is denoted by m as equal to tangent of this angle theta. So you can clearly see that this slope depends on the value of theta, that means angle made by this straight line with a positive x-axis. And therefore, correspondingly, if this theta is acute, as you can see in this figure, then the slope is going to be positive. Why this is positive? Because we know that tangent of any angle between 0 to 90 degree, the answer is positive. And therefore, if the slope is positive, we can say that the graph of this straight line is an increasing graph. So we can write this result that if m is greater than 0, it implies that graph is increasing. Well, now what will happen if this theta is obtuse? Let's try to have a look at that situation. This is the x-axis and this is the straight line, and you can see that this straight line is making an obtuse angle with a positive x-axis. Now what will be the slope in this case? Well, whenever theta is in between 90 to 180 degree, if it is obtuse, then tangent of any obtuse angle comes out to be negative. In high school, we do not talk about angles more than 90 degree, but in trigonometry here, we are going to talk about the angles which are more than 90 degree, and there we will see that tangent of any angle which is more than 90 degree and less than 180 degree, it comes out to be negative. So we can conclude that if theta is obtuse, it means that slope is going to be less than 0. And there is one more conclusion we can draw. If slope is less than 0, what it means, you can see that the graph is a decreasing graph. So we talked about the situation when theta is acute, when theta is obtuse. Now let's talk about the situation wherein this theta is 90 degree. Well, if this theta is equal to 90 degree, then what will be the slope? Well, in this situation, the line is going to look like this. This is going to be 90 degree. Now, what is tangent of 90 degree? Well, it is not defined. So in this case, we will say that the slope is not defined. However, we can say that if theta is approaching 90 degree, then we will say that the slope is going to approach infinity. So in physics, it is usual to say that whenever we have a vertical line, the slope of this vertical line is just infinite. And if you want to write the equation of this vertical line, it is going to be x equal to constant. Why x equal to constant? Because if you look at any point on this straight line, all these points are going to have same x coordinate, whereas the y coordinates will be different. And therefore, the equation of this vertical line will be x equal to constant. Now let's talk about a situation wherein this theta is equal to 0 degree. So if theta is equal to 0 degree, then in such a case, the straight line is going to be parallel to the x-axis. You can see that the angle made by this straight line with the positive x-axis is 0 degree. In fact, even if we say that this theta is 180 degree, then this straight line is going to be parallel to x-axis. It can be above the x-axis, along the x-axis, and below the x-axis. It will depend on the y-intercept if it is positive, 0 or negative. So the equation of the straight line in this case will turn out to be y equal to c, because m in this case is going to be 0. So we can conclude if slope is 0, then the graph is constant. It means that y doesn't change no matter whatever be the x, y remains same. So it is neither increasing nor decreasing graph. So we talked about all the possibilities with regard to the slope of the graph. Now we will talk about the formula related to the slope of a straight line if if the coordinates of the 2 points are known to us. So let's imagine this is the straight line, and the first point is coordinate is x1, y1, and another point is coordinate is x2, y2. So we have to find slope of the straight line. So what is the formula for that? Well, the formula for the slope of the straight line in this case is going to be y2 minus y1 divided by x2 minus x1. It's very easy. If you look at the x-axis is going to be parallel to this dotted line, and this is going to be the angle theta, and slope will be nothing but tangent of this angle theta. And if you look at this distance will be nothing but y2 minus y1, and this distance is nothing but x2 minus x1. So if you know coordinates of 2 points on the straight line, we can use this formula in order to find slope of the straight line. Well, now if I may conclude this equation of a linear function, this equation of a straight line of the form y equal to mx plus c. If we have this equation y equal to mx plus c, we can draw its graph. The y-intercept will be c, depending upon whether c is positive, negative, or 0. If it is positive, the line is going to cut y-axis on the positive side. If it is negative, it will cut on the negative side. And if it is 0, then we are going to have a spatial equation y equal to mx, which is a straight line passing through origin. And depending upon m, whether it is positive or negative, the graph would be increasing or decreasing 1. And if it is 0, then it is going to be a constant graph, that is y equal to constant. So this was the first form of equation of a linear function. Let us now talk about the another alternate form of a linear function. So the alternate form of a linear function would be x by a plus y by b equal to 1. What are this a and b? Well, this a is the x-intercept. That means the point on the x-axis where the straight line will cut x-axis, and b will be the y-intercept. That means the point where the straight line is going to cut the y-axis. So if you look at the graph is going to be a straight line graph again, obviously, and the x-intercept is going to be equal to a. Therefore, the coordinate of this point will be a comma 0, and the coordinate of this point, which is where the line is cutting the y-axis, is 0 comma b. So now if we can reduce the equation of a linear function in this given form, x by a plus y by b equal to 1, then in that case we can draw its graph quite easily, because we already know the x and the y-intercept. Well, let us now talk about the domain and range of this linear function. Domain means all values that the independent variable x can take, and range the corresponding values that the dependent variable, that is y, can take. Well, x will be any real value from minus infinity to infinity, so there are no boundations on x. Similarly, y can take any values from minus infinity to infinity in case of a linear function. So this is about domain and range. Let us now talk about finding equation of a straight line if few information is available to us. So the first situation is if the slope of the straight line and y-intercept, they are known to us. How to write equation of the straight line? Well, it's quite easy. In such a case, y will be equal to mx plus c. So this was quite an easy case. Let's talk about the second situation. Well, the second situation is if the angle theta, that means the angle made by the straight line with the positive x-axis, is known to us and the y-intercept is known. Again, it's very easy. The equation of a straight line would be y equal to tan theta x plus c. So this was also very easy. Let's have a look on the another situation. So if we are in a situation that the slope is known to us and coordinate of one of the point is known to us, then the equation of a straight line will be y minus y naught equal to slope. It can be either theta is known or m is known. Let's say m is known, so it is m times x minus x naught. So this is going to be the straight line in case the coordinate of any one point, which is x naught, y naught, is known to us. Well, in another situation, if coordinates of 2 points, let's say x1, y1 and x2, y2, they are known to us and the slope is not known to us, in such a situation, how one can find out or write the equation of a straight line? Well, in this case, it is going to be y minus y2 equal to y2 minus y1 divided by x2 minus x1 multiplied by x minus x2. So basically, if you look at this term is basically the slope of the straight line. And there is an alternate way in which you can write it. You can also write it in this manner, that the equation is y minus y1 equal to y2 minus y1 divided by x2 minus x1 multiplied by x minus x1. Basically, if y2 is here, it has to be x2 over here, and if y1 is here, it has to be x1 over here. So these are the two ways in which we can write the equation. Both are going to give you the same result. So we will use these equations when the coordinates of 2 points on the straight line are known to us. Now let's have a look at the last situation, in which if x-intercept and y-intercept are known to us, we know it quite easily that it is going to be x by a plus y by b equal to 1. So we can be in one of the various 5 situations that we have just talked about. If we are into any one of these 5 situations and we are supposed to write the equation of a straight line for some reason, then we can make use of these results which we have just written over here. Let us now have a look at the physical interpretation of linear function, which is very important for all practical purposes, because of which we are talking about the linear functions. So the linear function, let's have an equation y equal to mx plus c. In any function, basically it is a relation between a physical quantity with another physical quantity, that is y and x. Let's say these two are the different physical quantities, and the relation is such that if you change the x, y is going to change because y is dependent on x. In linear function, this is going to have a spatial relation. What is that spatial relation? It means in linear function that y is going to change linearly with respect to x. If you change x, then y is going to change linearly with respect to x. Now, what is meant by this statement that y changes linearly with respect to x? Well, let's have a look at this straight line and consider any point on the straight line. Let's say this is our point on the straight line. It has certain x coordinate and y coordinate, and let's say we try to change the value of x by a certain amount, and let's say the change in x is delta x. So this is your delta x, and corresponding to it there will be change in y. So this is going to be the corresponding change in y, delta y. Because we know that this y and x, they are related. If you change the value of x, you are going to get change in y. So this was the initial coordinate, and now we are going to get this as the final coordinate. Now, what is so special about this linear function that you make these changes anywhere else? Let us consider some other point on the straight line. This is some other point on the straight line. This is the initial value of the x, let's say. And now we make the same amount of changes in x, that is delta x. So x has changed by delta x. Corresponding to it, there will be change in y. And the special thing about this linear function is that if you make changes in x by equal amount, irrespective of where you are making the changes in y is going to be same. So earlier the changes was delta y, and therefore this time also the change is going to be delta y, because we made the change in x as delta x earlier as well as now. Well, this doesn't really happen in case of non-linear functions. In case of non-linear functions, the change in y is going to depend on where you are making the changes. What is the point on the graph where you are making these changes? Whereas in case of a linear function, it doesn't really matter where you are making these changes. And with this, we can simply say that delta y by delta x is basically equal to constant, and that is obvious because you can see in this graph this angle is theta, so this angle is also going to be theta, and therefore delta y by delta x is nothing but the slope. In other words, we can say that slope of this linear function is nothing but the rate at which the y is changing with respect to x, and we can note down this conclusion. That is, m is the rate of change in y with respect to x. So if slope is more, that means y is changing rapidly with respect to x, and that rate is constant because this m is constant. And if the slope is less, it means that y is changing not that rapidly with respect to x if you vary x. And in fact, if the slope is negative, it means that there is a change, but the change is negative. It means that y is decreasing with respect to x, however, at a constant rate. So this is the physical interpretation of a linear function. If two quantities are linearly related, it simply means that one quantity is changing at a constant rate with respect to the other quantity. Well, in fact, here we can consider a practical situation. Let's imagine that I earn 100 rupees every day. So if you try to plot a graph, or if you try to write an equation between my wealth and number of days, then you will see that the graph of wealth versus days is going to be a straight line graph, because the increase in wealth with respect to days, it is going to be constant. That means every day I'm earning 100 rupees. So that's a constant quantity. So this is how we are going to interpret a linear function practically. So that's all about the linear function. Let us now talk about the quadratic functions. So we need to talk about how the equation of a quadratic function look like. Well, there are various forms in which we can write the equation of a quadratic function. However, we will not talk about all of them. We'll be talking about only those equations which we will require in physics. Okay. So the first form here will be y equal to ax square plus bx plus c. You can see that it's a 2-degree expression in x and 1-degree expression in y. And if you try to plot the graph of this equation, the graph is going to roughly look like this. So it is either concave up or it is concave down. When we name this graph as parabola, and remember, not all curves are parabola. It is because the equation of this graph is a quadratic function, and therefore we name it as parabola. So it is either a concave up parabola or it is going to be concave down parabola. Well, it is going to depend on the value of a. If a is greater than 0, then the graph is going to be concave up. If a is less than 0, then the graph is going to be concave down. So this is the significance of the constant a, which is the coefficient of the x square. Now let's talk about the constant c. What is this constant c? If you put x equal to 0, then you are going to get y equal to c. It means that c is the y-intercept of this graph. So therefore, in order to analyze the equation of a quadratic function, it is very much important to have a look at the coefficient of the x square and the constant c. So if this constant c is positive, it means the graph is going to cut y-axis on the positive side, and if it is negative, then it is going to cut the y-axis on the negative side. And if this is 0, that means it is going to cut at y equal to 0 or simply at the origin. So apart from these two things, A and C, let's have a look at other things that we should be looking for. Well, other thing that we should be looking for is the x-intercept. That means the points on the x-axis where the graph is going to cut it. Well, there are in fact 3 possibilities which may exist. That is, the graph is cutting the x-axis at 2 points. This is one of the possibility. Another possibility is that the graph is touching the x-axis in such a manner that the x-axis is a tangent. And the third possibility is that the graph is not touching the x-axis at all. Well, of course, a can be positive and negative. I have taken the case where a is positive. So all these graphs are concave up graph. So what is going to determine which case it is going to be? Well, it is the value of the determinant d. What is this d? Well, d is basically equal to b square minus 4ac. So you just need to calculate this value b square minus 4ac. If d is greater than 0, then first situation it would be, that means the graph is going to cut the x-axis at 2 points. You already know that when we equate this ax square plus bx plus c equal to 0, we are going to get the x-intercept. That means it is a quadratic equations. We may get 2 roots, we may get 2 roots coinciding, and we may not get any real roots at all. So in the first situation, if d is greater than 0, the graph is going to cut x-axis at 2 points. One of the point is a smaller root. We can refer to it as x1. Another root, the bigger root, that can be referred to as x2. In the second situation, if d is equal to 0, then the graph is going to touch the x-axis. And the third situation would be if d is less than 0. That means the quadratic equation is not going to have any real roots. And in fact, we already know a specific relation between this x1 and x2. They are basically the roots of the quadratic equation, which we have already studied in our high school. We know that the sum of the two roots x1 plus x2 is equal to minus of b by a, and the product of the two roots x1 x2 is equal to c divided by a. In fact, we can actually calculate the value of x1 and x2 by using the formula that you already know, so I'm not writing it over here. And one more thing you can observe in all these graphs, that all these graphs, they are symmetrical about a vertical line. You can see that this vertical line, about this, all these graphs are symmetrical on the left as well as on the right side. So we can write the equation of this vertical line. This equation of the vertical line will be equal to, it is basically exactly in the middle of x1 and x2. So it is going to be x1 plus x2 divided by 2. And therefore, the equation of this vertical line is going to be x equal to minus of b divided by 2 times a. And it is not just in this first case, the equation of the vertical line is going to be x equal to minus b by 2a in the second as well as in the third case. So if I now can sum up all these things that we have studied, whenever we have a quadratic equation of this form, what all things we should be looking for? Number one thing we should be looking for is the coefficient of x square, that is a. If it is positive, the graph is going to be concave up. If it is negative, the graph is going to be concave down. The second thing that we should be looking for is the y-intercept, that is C, where the graph is going to cut the y-axis. And the third thing that we should be looking for is a value of b square minus 4ac. If it is greater than 0, then it is going to be the first case. The graph is going to cut x-axis at two places. And if it is equal to 0, then the graph is going to touch the x-axis. And if it is less than 0, if it is negative, then in that case, the graph is not going to touch or cut the x-axis at all. And in the two situations, when the graph is concave up, you can see that there will be a minimum value of y, maximum it can go up to infinity, and where you are going to get the minimum value of y, it will be at x equal to minus of 2 by a. And in case of concave down parabola, there will be a maximum value of y, and that maximum value of y again is going to be at x equal to minus b by 2a only. And in fact, with this we should be talking about the domain and range of this particular function. So in order to talk about domain and range, I have taken two situations. In the first situation, a is greater than 0. In the second situation, a is less than 0. So we can clearly see in both the situation, there is no boundation upon the value of x. X can take just any value. Therefore, x is going to be anything from minus infinity to plus infinity in the first case, as well as in the second case, x can be anything from minus infinity to plus infinity. Let's now talk about the range of this function. That means what all values y can take. You can see that in the first case, there is no upper limit of the y. It can go up to infinity. However, there is a lower limit of this y. That means y is going to be minimum at certain value of x. And we have already studied that what is that value of x at which y is going to be minimum. It is at x equal to minus of b by 2a. That y is going to be minimum, and therefore in the first case the range of the function is going to be a certain minimum value of y to positive infinity, and we have to include that certain minimum value of y. How we are going to get this value? We just put x equal to minus b by 2a in the equation. And similarly, in the second situation, if you look, there will be no lower limit of this y. This y is going up to negative infinity. However, there is an upper limit on the y. The upper limit on the y, that means it is going to have certain maximum value, and again it is going to be at x equal to minus of b by 2a. And therefore, the range of this function in the second case is going to be from minus infinity to a maximum value of y, which we can obtain by putting x equal to minus b by 2a in the equation y equal to x squared plus bx plus c. Let us now talk about the physical interpretation of the quadratic functions. So if we have a situation in which a physical quantity y changes quadratically with another physical quantity x, then what does it mean? So the first thing that we can note over here is that at different point, that means at different values of x, let's say this point is p and another point, let's say here it is q. So the slope at p will be different than the slope at q. What is meant by slope at p and what is meant by slope at q? We have already discussed slope in case of a linear function, which is nothing but the tangent of the angle made by the straight line with the positive x-axis. What is meant by slope in case of a non-linear function or non-linear graph? In any non-linear graph, the slope at any point is nothing but the slope of tangent at that particular point. So let's imagine the tangent at point P. So the slope of this graph at P is nothing but the slope of the tangent at P. So you can look at this red line which is tangent at P. So whatever be the slope of this red line is going to be the slope at the point P. And as I said that the slope at different point will be different. So if you look at this point Q, the slope at the point Q is going to be different. Why? Because if you try to analyze the tangent at this point Q, which is going to somewhat look like this blue line. Well, this is the tangent at Q. Now you can see that tangent at P and tangent at Q, these two lines basically they are having different slopes, and therefore in a non-linear function, not just in case of this quadratic function, in any non-linear functions at different points we are going to have different slopes. So what is so different about this quadratic function? So first thing that we will note is that the slope at different point is different, which is not just in case of quadratic function but in any non-linear function. So that is the first point that we will note over here. Well, as I said, slope at different points is different in not just in case of quadratic function but in any non-linear function. However, in quadratic function there is a special thing, that slope is changing with respect to x, but it is not just changing, it is changing at a constant rate. It is changing linearly with respect to x. So that is a second physical interpretation of a quadratic function, that slope changes linearly with respect to x. And in fact, we are going to look for the proof of this statement when we talk about the differential calculus. Now, lastly in this topic, we have to talk about another form of quadratic functions, that is y square equal to ax plus b. You can see that it is a 1 degree expression in x and 2 degree expression in y. This is exactly the opposite case of what we did earlier. It was 2 degree expression in x and 1 degree expression in y. Well, in this case, the graph is again going to be a parabola, but this time it is going to be either a concave left parabola or it will be a concave right parabola. It will depend on the coefficient of x, that is a. If a is less than 0, then it is going to be concave left parabola. If a is greater than 0, then it is going to be a concave right parabola. We'll not talk about y-intercept over here. We'll talk about the x-intercept, and in fact this graph is going to be symmetrical about the x-axis. So this is your x-axis in the left case and this is your x-axis in the second case. So what will be the x-intercept? That means where this graph is going to cut the x-axis, it is going to cut the x-axis at this point where y is equal to 0. That means that x equal to minus of b by a. And here also the x-intercept will be x equal to minus of b divided by a. Now we can talk about the domain and range of these functions. In the left side of parabola, if we talk about the range, it is going to be from minus infinity to plus infinity, because we can see that y can take any value from minus infinity to plus infinity. Similarly, in the right side, in the concave right parabola, the range is going to be from minus infinity to plus infinity. However, the value of x cannot take any value from minus infinity to plus infinity. So as far as the domain is concerned, the domain is restricted. For example, in the left side graph, the value of x will be from minus infinity to a maximum value. And what is the maximum value of x? Maximum value of x is going to be minus of b by a, and we have to include it. And what about the domain in case of the second function? Domain in case of second function will be a minimum value of x is going to be minus of b by a, and maximum x can be infinity. In fact, you can have an idea about these domains also from looking at this equation in this form, that y can be written as plus minus under root of ax plus b. So from here also you can get an idea about the domain. The domain cannot be from minus infinity to plus infinity, because this quantity ax plus b has to be greater than or equal to 0. And from there we get that the x cannot be anything from minus infinity to plus infinity. So this is all about the linear and quadratic functions. And now if you want to solve problems specifically related to this topic only, and you do not want to waste time in finding problems in your books or elsewhere, then you can check out my application, whose link is provided in the description box below. Thanks for watching.